Hi everybody, in this session I would like to tell you about torsion, twisting moment related problems for mechanics of materials. Torsion is very similar to tension, but the direction is different. Instead of force, we deal with some twisting moment. When you consider a cylindrical bar like this one, externally, some torque is acting like this one. Twisting moment is like this one, acting like this one. Okay, when you consider its length is L, and the material itself has some stiffness. Let's say shear modulus of elasticity, G, is given like this one. And G is, of course, expressed in Newton per meter squared. And here we would like to know the change of angle phi. Let's say this line was changed, let's say like this one. We are dealing with the change of angle, this phi. Phi, of course, is given radian. T is Newton meter and L is meter. Okay, that's given for cylindrical cases. Then here we have the governing equation for change of angle. Of course, the cylindrical bar is under elastic range. Phi equals what? G I P T L. The governing equation is, the governing formula is like this one, expressed like this one. Here we have IP value. IP is what? Polar moment of inertia. Polar moment of inertia, which has integral a r squared dA, r squared dA, r squared dA. And of course, this one has the dimension of meter exponential 4, meter exponential 4. And this one is governing equations. The change of angle phi radian equals TL over GIP. That's the governing equation. We can reduce this formula like this one. When you change this one, phi over L, let's say this one is theta. Theta can be expressed like this one, GIPL. Okay, this one is also frequently used for solving real problem. Theta is change of angle in meters, for example, degree or in meters, or radian in meters. That's also available. Sorry, this one is not L, this one is T, let's say T. L is over there, and GIPT, that's also given. Okay, both of them. Another one is tau maximum, tau shear force, which was happened on there, on the cylinder. This one is also applied IPTR. Okay, first formula. This one, tau max gives like this one, and change of angle also given TL over GIP. This formula is frequently used. And IP, this one, IP. Polar moment of inertia can be calculated like this one. And when you apply both of them, phi value, change of angle, and tau max, maximum shear stress. When you apply this formula, you can solve most of the problems related to torsion. Okay, let's tackle one of them. The first one, example 1. We have a cylindrical bar, or cylindrical bar like this one. When you cut here, inside is full. is solid shaft, and both end torque twisting moment T is acting like this one, and it's made of steel, and diameter is 40 millimeters, and length is 3 meters. And when you calculate, the unit is different, and inevitably you must convert this one to millimeter, or millimeter to be converted to meters. Otherwise, final answer is totally different. And the shear modulus of elasticity G is given 80 gigapascal. Giga is 10 exponential 9. Pascal is Newton per meter squared. This kind of unit we have. And twisting moment 340 Newton meter. And we would like to know change of angle phi, or tau max. And next one, the first question is like this one. Next question is like this one. When allowable shear stress is given, or allowable maximum change of angle is given like this one, then what's the maximum twisting moment? Please find that. That's the question. Okay, let's see step by step. First one, we would like to know phi and tau max, and we can calculate phi. How we can calculate phi? Phi equals G IP TL. Okay, when you apply this one, then you can easily calculate phi value. Here, polar moment of inertia, IP equals, in the case of a circle, phi over 32, d exponential 4. Then we can calculate the IP value for this one. IP phi over 32, d is what? D is 40 millimeters, exponential 4. Then you can calculate the IP value. And you know this one, and the G is given 80. Be careful about gigapascal. The unit is different. Okay. And torque is given 340 Newton meter, and L 1.3 meter. Then you can calculate final value. Okay. Here, be careful about the unit. Unit is given in radian. By definition, when you give some MKS unit, finally you can have the value in radian. That's the phi value. Next, we would like to calculate the tau max. Tau max is given by IP IPTR. Okay, we've already calculated the IP value here, and T, torque is given, and R, radius is 40 by 2, then 20 millimeters. Then you can have this one, and this one, tau max can be Newton per maybe millimeter squared, or you can have Newton per meter squared Pascal. You can have. Okay. By applying the formula, directly like this one, phi and tau max IPTR, then you can calculate the values change of angle and maximum available shear stress. We can calculate. Next, we would like to find T max, this value, this T value, okay, what is this T value? Okay, when you see both one, when you apply this condition, phi max is given, applied, you can find here Tmax value by applying maximum allowable change of angle. Another possibility is when you apply maximum shear stress, tau max value, then you can also find Tmax. Okay, we can compare finally by applying this condition or this condition. Then finally we can take the worst one for safer one. Okay, let's apply this one first on the left one. Here we can calculate Tmax is calculated, can be calculated, and phi g I p l GIPL, and phi is given here. When you apply degree, then please convert into radian value. This, and shear modulus of elasticity, you can have 80 gigapascal. IP is given by, on the left side, this one, L is given. Then you can calculate by applying this formula. We have one maximum. It can be written in Newton meter. Next, you can calculate applying this one on the left side, this one, and apply this one. And here Tmax is expressed tau max, and IP, polar moment of inertia, and is divided by R. And tau max allowable shear stress is given by here, and IP also given here, and you can apply radius R, and you have also some answer, some solution like this one. When you compare, this one is, the first one is 1, tau max 1, and tau max 2. When you compare both of them, if you take the safer case, the worst case, then you can finally what's available applied twisting moment. Okay, that's the for example 1. In this example, we actually applying this relationship, phi equals TL over GIP. That's basic one. And another formula, tau maximum is TL over IP. When you apply this one, you can have simply get final answer. Okay, that's for example 3.1.